Out of Year 12, I'm going to go on with our work that we did in class. The equations, we did parametric equations of the chord, of the ellipse, the hyperbola, and indeed the circle. We also did tangents and normals. Now I'm going to finish it off. I'm going to do chords, the chords to the ellipse and the hyperbola. So the first thing you need to know is a couple of things, and you should remember these from when you were in, or from your early extension 1 time. Sine of, and these are on your reference sheet, but they use theta and phi. We're going to use A and B. So sine of A plus B is sine A cos B plus cos A sine B. And you can do the addition. Or we'll stick here with the sign. All that happens when you subtract them is that the sign changes. Now, if we call that equation 1, and we call that equation 2, and we're just looking at the red at the moment, if we add those two together, if we add sine A plus B plus sine A minus B, we're going to add those two things. The cos A sine B will eliminate, leaving us with just 2 sine A cos B. Now, if we subtract those two equations, if we go 1 minus 2, so over here, this is 1 plus 2, and this is 1 minus 2. If we subtract them, sine A plus B minus sine A minus B, the sine A cos B will eliminate, and we'll get 2 cos A sine B's, or putting the sign first, sine B cos A. Now, if I do a similar thing here, if we look at the cos A plus B, and again that's on your formula sheet or your reference sheet, is cos sine with a minus in the middle. And again, the only thing that changes when you do cos A minus B, you get cos sine with the plus in the middle. And again, if I call that equation 1, and I call that equation 2, and I add them together, I'll get cos A plus B plus cos A minus B. And if you look closely at that, the signs will eliminate. So sine A sine B and sine A sine B will eliminate, leaving us with 2 cos A cos B. So that's adding equation 1 to equation 2. If I go equation 1 minus equation 2, cos A plus B minus cos A minus B, this time the coses, the cos A and the cos B, will cancel each other out, but I'll get minus or negative 2 sine A sine B. Now we're going to be using those, so it's important that you understand how I've come at those. So I'm just going to do a little bit of algebra now. So this is not to do with that, but it will work out. If I say I let A plus B equal an angle. Now you can see what I'm doing now. We'll call it theta. And we'll say we'll let A minus B equal a different angle. Call it phi. Okay. If I add those equations together, so again, if I do something like this and call that equation 1 and call that equation 2, and I add them together, if I add them together, I will get 2A equals theta plus phi. If I subtract them, right, so that was adding the equations, so that's 1 plus 2. If I now go 1 minus 2, well, I'll get 2B, and I'll get theta minus phi. So therefore, I can say that A equals the 2 angles added and halved, and B equals the 2 angles subtracted. and halved. Now, if I now put these in to those equations, if I look back up here and I want sine A plus B. So, sine A plus B plus sine A minus B, which is sine theta plus sine phi. We know that sine A plus B plus sine A minus B, according to a law, is 2 sine A cos B. So it equals 2 sine A cos B. That's from these things up here. Right, look up here. And it's this bit here that we're looking at. 2 sine A cos B. And of course, A, if we're using theta and phi, is 2 sine theta plus phi over 2 cos theta minus phi over 2. And if I do the subtraction, now I'm not going to use A's and B's anymore, I'm just going to use theta and phi. I'm going to use, if I do sine theta minus sine phi, you're going to have to look back now. I'm going to get 2 sine B, which is theta minus phi over 2. And I get cos A, theta plus phi over 2. Now, if I do the cos versions of these, cos theta plus cos phi. If I look back, that'll give me 2 cos A, theta plus phi, phi over 2, cos B, theta minus phi over 2. And if I do cos theta minus cos phi, I'll get minus 2 sine A, which is theta plus phi over 2, sine B, which is sine theta minus phi over 2. Now that's just a bit of a substitution with your trigonometry, using those laws and letting A plus B equal theta and A minus B equal phi. So 2 different angles. Now how do we apply that? Okay, so we need an ellipse. So we'll get an ellipse. Oops, I didn't want that there. So I'll undo that. Let's try down here, so we can get it in the right spot now. Don't go up there. Come down here where we meant to. Let's see if I can get it in here now. There we go, that's what I want. So I've got this ellipse. And if I now plot 2 points on it, one there and one there, doesn't really matter where they are, and I join them. And I'm going to use a parametric form of these two. So we'll call this one, now remember our parametric form, A cos theta and B sine theta, which are parametric form on the ellipse. And I think we'll call, I don't know, I'll use the same notation as Patel. I think he calls them P and Q. Yeah, so he calls that point P, puts it on the other side, but it doesn't matter. We'll call that point Q. And then for Q, we'll go A cos phi and B sine phi. And what we want to do is we want to find the equation of this chord. Well, remember we're going to use y minus y1 equals m outside of x minus x1. So I need a gradient. And the gradient's pretty easy. All I've got to do is just use the gradient formula. So m equals the y values. So b sine theta minus b sine phi. And underneath I've got a cos theta minus a cos phi. All right. So what I'll do is I'll factorise out the b and the a. So I'll get b, and then here I've got sine theta minus sine phi. Oops. And here I've got a outside of cos theta minus cos phi. Now, I know that sine theta minus sine phi. Didn't we just do that? Sine theta minus sine phi, there it is. Look up here, there it is. Well, that's not what we want to use. We want to use here. Sine theta minus sine phi. Here, we want to use this. Which is going to be, because it's going to make it easier. So we're going to get b on a. And we're going to get 2 sine b cos a. Because remember, a equals theta plus phi on 2. And b equals theta minus phi on 2. And underneath, cos minus, I'm going to get minus 2 sine a sine b. I wanted to keep the b in there because it just makes it easier so that when I cancel, they go, the 2 goes. So what do I get? I get minus b on a cos a on sine a, which gives me minus b on a cot a. So now I've got my gradient. Now if this little bit here confused you, just remember I'm using this, and that is here, that's your b. See the b here and the b here, and that's a. You see the b here, oh, okay, yeah, okay. And underneath, that's your a, and that's your b. Can you see? Down here? Okay. So I get minus b on a cot a. So here I go for my equation. Remember, it's y minus y1 equals m outside of x minus x1. So what do we got? So remember, our y values, we can choose whatever we want. So I think on the ellipse, I'll go for a cos theta and b sine theta. I won't use phi. I could use phi, it wouldn't make any difference, but I'm just going to go with that. So it's through the point, a cos theta minus b, and sorry, not minus, and the other one is, the y value is b sine theta. So you get y minus b sine theta equals minus b on a cot a x minus a cos theta. All right, we'll multiply the a across, we get Sorry, no, we'll just rewrite this. Y minus B sine theta equals minus B. I'm going to write this as cos A on sine A. And here I've got x minus A. I've got an A down here. Cos theta. So I'll multiply the A across, so I get A, Y, and sine A. So multiply all that across, multiply all this across up here. A, Y, sine A minus A, B, sine A, getting a bit messy, sorry, sine B, sine theta. And over here, I've got minus bx cos A plus AB cos A cos theta. All right, so it looks a bit ugly. Now, I'm going to divide everything. Well, I'll rewrite this. I'm going to have if I put everything, I'm going to pull this. I'm going to pull this over and put it with the Y. And I'm going to take this over the other side. So I get AY sine A plus BX cos A equals AB cos A cos theta plus AB sine A sine theta. Now, if I divide everything by AB, so I'm going to divide everything by AB. So I'm going to get, and what happens if I divide this by AB? The A will cancel, so I'm going to get Y on B sine A. Just make sure you understand that. I've divided by AB, and the A's have cancelled. I'm doing a bit of a quick step. If I divide here, I'm going to get X on A cos A. Okay. And here, I've still got cos A cos theta. Well, this looks like something I'm used to. Plus sine A sine theta. Okay. Let's rewrite this so that the x's first. X on A cos A plus y on B sine A equals, well, this is cos, actually I want to rewrite that a different way. I'm going to write that as cos theta first, cos A, plus sine theta sine A. Now the only reason is because I want the theta to be first. So now I know that cos theta minus A is equal to all that. But I also know that A equals theta plus phi on 2. So I'll put that in. So I get equals cos theta minus, I don't need the parentheses there because it's on a fraction, theta plus phi on 2. Well, cos 2 theta minus theta plus, sorry, that'll be minus phi all over 2, which gives me cos theta minus phi on 2. and thus I get my equation. If I also go here and put the things in for A there, so I go x on A cos theta, because that's A, plus phi on 2 plus y on B sine theta plus phi on 2 equals cos theta minus phi on 2. And that is the equation of the chord to the ellipse. Now, I can do the same. And come up with the equation on the hyperbola. I can do the same. It's a long proof, and it uses the same principles. I might make another video for that one. All right.